if we just like are like, here's the code, this is what it does.
It's a little bit. Like, it's a little more useful to walk through, like step through it, because you can actually like narrate the process.
Yeah. So I can do that. I think that sounds good.
Yeah, it's a little bit.
Okay, we are now streaming on YouTube. Let's wait a couple minutes and then you guys can go ahead.
Cool. Sounds good.
What the hell kind of a word, Rohan?
Oh. I'm apparently like incapable of typing. Yeah. Sorry about that.
What a weird word.
Yeah. I was like, yeah.
All right. I think you guys can go ahead and get started.
Okay, sounds good. I will.
Really quickly, someone asked if this is going to be recorded and sent. Yes, this will be available on our YouTube channel literally right after the workshop is over. So you're welcome to watch it right after as well.
Can the host enable screen sharing real quick?
Rohan.
Yes, let me do that. Cool, you should be able to now.
All right, go. Hope everyone can see my screen.
All right, so welcome to the intermediate Learnathon workshop on Python. I guess we'll go ahead and jump into it. There are a few things I wanted to say before I talked about data structures. I think data structures is like, the essential sort of starting point for learning how to move things around and manipulate variables and data in a programming language. It's useful to know how they crop up because it's pretty much the same set of data structures no matter which programming language you're in. It can be a little bit funky in Python. The thing that makes Python so easy to read is that you really don't deal with a lot of the internals of what variables you set up. It's a weakly typed language, so you kind of have to, if you know how to handle the syntax of setting up data structures in Python, it makes it a lot easier to not run into really weird errors, things that are a little bit, harder to comprehend or take a little more experience to unwind and figure out what's going on. But with that being said, the most basic sort of data structure you can use in Python is a list. A list is analogous to an array in something like Java or C++. It's just an ordered one-dimensional collection of elements. You can initialize it with an initializer list, which is just any number of elements between square brackets. And then you can index in and get either one item with a single integer, or you can take slices where you put two numbers between a colon.
Yeah, so creating a list in Python is pretty simple. You just want to do something like list one, so whatever you want to name your list. And then you just put square brackets here. And if you want to initialize your list like with elements already existing inside of it, you can just like, put those in. So you can put anything inside a list. It doesn't actually all have to be the same same type, but usually you'll have them be the same type, just because it's a little bit more useful that way. And then say if you want to like retrieve. Oh, wait, I should probably mention for this workshop we're using Google Colab to show you guys all of the code and make this a little more structured for you guys. So if you guys want to follow along, it's super easy. Just look up like Google Colab on Google and open up a new Python notebook and just kind of follow along as we go through the code.
Yeah, there's a plus code in the top left corner, so you can separate out all of these, and then you can also take your own notes with the little text boxes if you want.
Yep. So once you open up a notebook, you can just press plus code to add a new code cell. And then whenever you want to run any of your code cells, you just press this little play button here, and it runs this entire block. So yeah.
So that's how you run code. I was trying to do it earlier, and I ended up just pasting it into the terminal. I felt dumb.
Oh, yeah, it's a little hard to get the hang of at first. Not super intuitive, but so yeah. If you guys want to follow along, just open that up. So like I was saying earlier, if you want to retrieve the element at a specific index, that's generally how you want to access the data within these lists. You can just do like print for demonstration, do item at index 3.
So how you read that last expression, you're converting what's between the parentheses to a string, and what's inside those parentheses is the ith element of list one. So in that case, it would be the third element, or I guess the fourth, because since it's the third, lists are all 0 indexed. I didn't realize that I was 3 here. So the first element is the 0th element. The second number appearing is referred to as the first element, and so on. And so the item at position 3 would be 5 in this case.
Yep, exactly. Okay, and then Python also has this really useful feature that not many other languages have, which is the ability to slice lists. So how you would do that is you can just do like I don't need to convert it to a string. So what this notation means here is that we're retrieving a slice from the first, from the index 1 element that ends at the index 4 element. So this last number is actually not included in the slice. So really this is like indexes 1, 2, and 3. So you can see here indexes 1, 2, and 3 are 9, 8, 5. And if we run this right here, you'll see we get the slice we were looking for. And we can also add to the end of a list by doing like list one dot append, I don't know, 9,000 or something. And then if you print out the list, you'll see that, it added another element at the end of the list right there. And if you want to remove the item at an index, you can do like list one dot pop, and then the index. So if we do this, it'll remove the second index, which is the value 8. Yep, just like that. There's also insertion, so you can do like insert and then the index and then whatever you want to insert. So let's say like 49. So this will basically, yeah, insert the value 49 at index 2, and it'll push all of the items already in the list that is like past index 2, like back one spot. So you can see 5 was in index 2, but now it's 49, and everything after it got pushed back. And then finally, like one other really useful thing is like list.sort. So this just sorts a list, and you can actually specify some different, like you see here, it says key equals none. You can actually tell Python how you want the items to be sorted, but by default, it'll be sorted in ascending order. So if we just do like print list 1 here, you'll see all of the elements have been sorted from least to greatest. So yeah, that's just a very basic overview of lists in Python. Like you can dig a lot deeper, and there's a bunch of other different methods you can use, but yeah, those are the basics. So do we have any questions in chat? I don't know. I haven't been looking.
I was looking, I didn't see any. Because we can wait for a beat and then we can just jump in the dictionaries if nothing in particular shows up. All right. I think we're good. So lists are good whenever you can sort of organize your data by numbered elements, right? Like say if you just are keeping track of like a large set of homogeneous objects, you can just throw them all on the list. But sometimes the ways in which you want to access data may be a little more complicated than just numbering them. And so it's a little more useful to have a data structure that can associate keys that aren't numbers with data values. And dictionaries are how you do that in Python. They're analogous to maps in C++ or Java. You basically put values into a dictionary based on 2 parameters, a key, which is what you're going to use to get that value back later on, and a value, which is what you're primarily interested in storing. You can make an empty one with simple curly braces or by calling the constructor for a dictionary. You can also put key value pairs separated by commas and just list them out in curly braces and initialize a dictionary that way. And then to access those elements, you have to know that the key is there, and you can use square brackets. If you're not sure a key is there, you can use get, and it'll just return none if it's something that's not there, and you don't have to deal with the key error. So I tend to use get if it's going to be some sort of record that I'm not sure what all is in it, or I'm checking for things that might not be there.
Yeah, so as Nate was saying, like you can create an empty dict with these curly braces right here. Yeah, as you guys have probably realized, like you don't really use curly braces for like scope or like blocking off like portions of code like you might use in other languages. So that's that's how I use them in Python basically. But anyways, if you want to add or replace a value for a certain key, you can just do like something like this. So I think this is like a decent example of what you might see like a dictionary be used for. So like here I'm creating like, like a supermarket or something. And I'm just like, the key is going to be basically like the item that the market is selling, and the value represents like the price of that item. So this is how you would say basically like, oh, we want to like store like a milk object within this dictionary and give it like a value of 4. And then we can do something similar with other items like, let's say bananas are worth like $3 or something. Then chocolate is worth like $10. So now all of these are going to be in our dictionary, which see if you just print out the dictionary here. So yeah, it shows you all the keys and their respective values.
And
so
that printout is also exactly how you would initialize a whole dictionary at once in line. Like you could set the market variable equal to that thing that got printed out, the key value pairs between curly braces, and it would look the exact same under the hood.
Yeah, so Nate is saying like if you do this, it works the same way. Yep.
Python is able to make sense of that with no issues.
All right. So yeah, I guess something else to note is that in dictionaries, you can't have duplicate keys. So if you were to do something like, if we wanted to update the value for how much banana is worth, we could just like do that here. And then, let me get rid of this. Like you can see here, instead of like, adding another key called bananas or something like that, it just went ahead and was like, oh, bananas is already in the dictionary. So I'm going to go ahead and update the value. And then what else did we have? Yeah, so if you want to retrieve the value for a key, you can just do like, market and then square brackets and then the thing you want. So like chocolate here. And if you run this, like they'll get the value. And Nate was saying you can also do .get, I believe. So 2 ways to do the same thing, basically. Then something that's really useful if you want to know what you actually have in the dictionary and get a list of all the keys, you can do like the whatever the dictionary is called, .keys. And this will just give you a list of all the different keys that are in the dictionary.
I believe you can also do .values and you get the value set.
Yes, I think you are right. So this will print instead of all the keys, it'll print all of the values within the dictionary. So in this case, it should be 4 to 10. Yep, cool. All right.
Still no questions in chat. I think we can just skip on to tuples. So tuples are like sort of a particular data structure. They are going to crop up a lot in Python, but they don't have a super direct equivalent in other languages because they're basically immutable lists. So with a regular list, you might have some block of memory that the computer is managing for you, and you can put things in that memory block and you can take things out of it and you can mess with, the actual bits representing your information there. What tuples do instead is every time you reassign whatever variable has a tuple, you're creating a completely new version of the tuple every time. So what's sort of useful about that is since they're guaranteed not to change, they're often used as keys into dicts and things like that. Or sometimes you just use them anywhere that you might just store a value and then not have to change it again. So sometimes it's also useful as a set of like initial conditions or things that are constant or the same every single time. They're not super powerful on their own, but they get really useful when you put them in conjunction with other kinds of data structures.
Okay, right. So tuples or tuples, however you want to pronounce them. So to create one, it's pretty similar to a list. The only difference is that instead of using the square brackets, you're actually going to use regular parentheses here. So as Nate was saying, like one of the usual uses for tuples is that they're going to be like your keys for the for a dictionary here. So for example, if you have some kind of weird like, you know, data you're working with, or like, you know, somehow like, let's say you have all of these different types of values and whatever, and they all represent like one object. Like maybe this is like, you know, you're like a researcher and you're studying like animals or something, and this is like the size of like a lion, or I don't know. But you can just like think about this as like one kind of object that you can use to like reference as like a key to a dictionary or something.
My favorite classic example is just like an ordered pair. Like if you wanted to work with a coordinate grid environment, or you were doing something geometric and you wanted to keep up with like, you know, what's going on in the actual two-dimensional space, you can keep track of, you can map values to specific coordinates instead of just having to do one value. And so it basically lets you like have multiple keys for a certain value, because you can just have one tuple that has all the keys that you like, and you can access it through that tuple.
Yeah, that's a great example for sure. So I think the methods and stuff for a tuple or tuple is basically the same as a list. The only difference is you can't modify the values within the tuple. So if we do like, you know, print tuple one, like you would do, you know, square brackets 1 to refer to the first index. So this should print out lion. Yep. And I think most of, yeah, like you can also do slices. You can't really append
Under
or
pop,
remove.
because then you'd be making a new tuple.
Yep. All right.
Sorry, I cut you off. Do you have anything else for tuples, Bo?
No, I think we're good.
All right. So the last big one that you use a lot is sets. Sets are also unordered and they're one-dimensional, but you don't really access things out of sets. You put things into sets and then you ask the set to tell you whether an object is in the set or not in the set. So it's really useful for lookup, and that's its main purpose.
Yep. So we can create a set just by calling the constructor. If you don't know what that is, we'll talk about object-oriented programming in a little bit. So, so like, yeah, this is how you create a set. And to add elements to the set, you simply use the add command, the add function. So, so we can do like, and then, oh, by the way, we're going to be posting this workbook on our Google Drive, and I'll send the link at the end of the workshop. Type today. Okay. Oh yeah, so another thing about sets is that they also don't allow duplicates. So they're very similar to dictionaries on a conceptual level. The only like real difference is that dictionaries also like for each thing in them, they have like a value attached, whereas sets are just like the things themselves. So you can think of like this previous example. You could have a set that's like just milk, bananas, chocolate, and it would be like kind of, you know, just like all the items that are in the market, but like without the prices attached, I guess. So I guess it's not quite as useful there.
Sometimes sets are like used a lot in situations where you might have like a known range of values or like set of conditions, and you're just trying to check like whether certain ones have been met or not, because lookup is a constant time within sets. So it's the most efficient thing. Like say if you're trying to check if an element that you're processing is something you've already seen before, if you have a set of objects that you know all the objects you've seen, you can use it to check for duplicates.
Yep. So like here, you can see that even though we like tried to add banana 2 times, it only shows up once in the final set that we printed, just because Python doesn't allow you to include duplicates in a set. So like Nate was saying, they're mostly used for like lookup. Basically, you just want to be able to check really quickly if they're like if something exists within a set. So you can just do like whatever you're looking for. So you can do like pair in set 1, and this will just tell you, this will return a Boolean value that tells you like if that thing is in the set. So I guess like that's it. Like it sounds pretty abstract and we're talking about it, so I wanted to kind of demo like a pretty common problem. I'm not sure if you guys have seen this problem before, but basically we're trying to check if there are 2 numbers in this list that add to, I mean, it can be whatever number we want, but we'll say like we want to check if there's 2 numbers that add to 15. So like as a human looking at this list, it's pretty obvious that there are 2 numbers that add to 15, 4 and 11. But like trying to, I guess, translate that to like an algorithm is probably a little bit more challenging. So a really simple way to do this problem is you can actually use a set here. So we create a set called scene. And then what we can do is we can iterate through the array. So for num and nums. Not sure if you guys have seen this notation before, but this is just saying we're basically telling Python to go through nums, which is our list, and it's gonna give us like 1 element at a time, and that the value of that element is going to be contained in the variable num.
Yep. The important thing there is that the in keyword in Python looks for any object or type or variable that's iterable. And so as long as you have something like a list or anything that implements that interface iterable that lets you kind of walk through it, that in keyword will work.
Yep. So what I'm doing here is basically I'm going to go through the array, the list here, and basically check to see like for 9, if we want to add to 15, we're going to need like 9 and 6. So I'm going to check if we've already seen the value 6 before. And if so, then we can say that, we do have 2 numbers that add to 15. It's going to be 9 and 6. So we can do like print sum to 15 or yeah, and then basically for each number that we go through in the list, we want to add it to our scene set. That way, as we go through, like we can check if like we've already seen 14, 4, 8, and so on. So if we run this, there we go. So yeah, basically like if you want to like kind of trace this in your head, what happened is that we added 9 to the scene set, we added 14 to the scene set, we added 4 to the scene set, we added 8 to the scene set, and then once we got to 11, this if statement got triggered, so 15 minus 11 is 4, and 4 was already in our scene set, and it's like, okay, cool, we found it, and then it just printed out 11 and 4.
I like that example. All right, so a little bit about when to use all of these. Lists are your friend, generally speaking. It's where you should store large amounts of data, especially when that data is of a single type, and it's data that you might need to move around or change what's in it, add things, delete things. Um, they resize on their own. They're pretty easy to manage. So you should definitely use lists if you don't have a particular reason to use something else. You should use dictionaries when you're motivated in tracking particular associations between two related kinds of data. This could be a product ID and a price. It could be a tuple of coordinates and some sort of utility value for being at a space on the coordinate grid. If you were coding a game, for instance, or something. So yeah, whenever you need to map one particular kind of data to the other, you should use a dictionary. You use tuples when you're trying to create immutable representations of data, things that will stay exactly as they are. So when you're trying to you can basically make your own constants out of tuples. You can make useful combinations of variables that then either become keys or their own kinds of data that you can use elsewhere. We didn't demo it, but if you look into how tuples can kind of be packed and unpacked, it's a really nice way. Sometimes if you just need to pass a lot of information one time and unpack it at a different spot in your code, tuples are also really good for that. And then with the demo sort of really covered it quite well. You use sets in the case that you need fast lookup, because instead of having to walk through every item in a list and say, is it this one? Is this what we're looking for? Sets are implemented in such a way that they don't have to walk the entirety of their data structure to know. They usually use a hash table or something like that. But yeah, I still don't see any particular questions in the chat about data structures. This is your last call because we're about to jump into object-oriented programming. All right, so very, very simply, object-oriented programming is just a custom way to organize your data structures as a hierarchy of objects, or sometimes you could call it like a hierarchy of concepts, but you just, when you need meaningful inheritance or parent-child relationships between your data. For instance, like, thanks, sure, Steve. For instance, like, if you wanted to implement something to represent, say, a car, and then have specific things underneath that, like I think we're going to end up with a truck. And the basic idea behind using object-oriented programming is that you want to encapsulate things, so an object's in charge of its own state, and you don't have things managing different objects strewn all around your code. You want abstraction, so you don't have to worry about what objects are doing. You just ask it to do something, it hides its activity, and it comes back to you with a nice, clean result. You want inheritance, so that way you can pass down functionality from some more generic category to specific instances of that idea. And then you want the opposite as well, polymorphism, which is that, specifications on a particular concept might be a little bit different than their parent category. Like how, a truck could have a different type of engine than a car, but that doesn't make it not a car. This concept is pretty nebulous. It's very fundamental in programming. Everybody has their own preference as to how to explain it. You should definitely look at some educational resources for the theory of how object-oriented programming works, because I could not do it justice in, an hour. So definitely not in 5 minutes.
Yeah, for sure. But yeah, we can look at how to very simply, I guess, like implement some of the object-oriented basics within Python. So one of the most important things is that in pretty much all object-oriented schemes, like you have the concept of a class. You can kind of think of a class as maybe like a blueprint for creating an object. So basically our class car is going to tell us like all the things that make up a car and how to actually like create a car, and something like that. So the first thing like that you have within a class, you can have class variables. So these are shared between instances. So basically what that means is like all cars will have like this variable. And it's going to be like the same for every car. So like, for example, like we can say like, you know, all cars are made of like steel or something like that.
This is analogous to if you have any experience in other programming languages, like maybe some common ones like Java. This would be like a static variable. This is something that belongs to the class itself, and all members share this property sort of identically. You know, all cars would be made of steel.
Yep, exactly. And then we have the constructor for a class. So this is what is called when you create a new instance of this object. So whenever you want to make a new car, you're going to call this constructor. So it needs to have some important, I guess, information to tell Python like what kinds of things are, you know, make up a car and like what the specific car has. So the way you define a constructor is with 2 underscores and then init. And then 2 underscores, and then you have to pass self to the constructor, which I guess is kind of abstract, but it's basically just saying that the constructor needs to be able to access like its own, like the instance of the car.
Yeah. So the sort of idea is that anytime you call init, you'll make a new car. And once you do that, you've made an object of the class, and a specific object of that class might have, you know, individual properties that aren't just its class properties. And so it needs to know, like, the reason that all instance methods take the self parameter is because it refers to a specific instance of that class. And so it needs to know, like, you know, this is me, this is what information, you know, is available to my particular instance of the car class. And it is referring to the fact that each of those different instances will have their own spot in memory. And so self is just self is how each object knows that it's a particular object.
Yep. So to assign instance variables, okay, so instance variables are like Nate kind of explained, was like the things that are specific to each instance, or like you can just think of it as like in this example, like for each car, right? Like each car is going to be different. Like each car is going to have its own color, year, make, model, and so on. And you want to be able to like specify all these things for each individual car. So how you can do that in Python is by using like self dot and then whatever variable name you want. Like it doesn't actually have to be the same as what you're passing to the constructor, but I just did that for simplicity.
Yep, that's typical convention, but you know, it's basically just self dot my variable can be whatever you want from the parameters passed into init.
Yep. So these lines right here are just simply like assigning the things that we pass into the constructor to the actual instance of a car. And then within a class, you can also have, you know, you can define whatever variables you want. Okay, variables and also methods. So like we can have maybe like a get price method. So like this method might, you know, calculate the price of a car based on all of like these various properties of itself. So we could do something like simply, maybe the base price is 25,000. And then we can say like if it's a newer car, like maybe newer than 2018, and we can be like like 3,000 or something. And maybe like if if it's red, like maybe red is like an expensive paint color or something. Like another 1,000 on top of it or something like that.
Maybe we should jump in right here and just do a little about functions, because I think we haven't said anything particular on that topic. I don't know if that got covered in beginner or not. But the keyword def there just means that you're defining a function. The thing that comes after it is its name, and then you put parameters, which is what the function expects to get between parentheses. The self parameter sort of disappears when you actually call something, so you don't ever have to give like an instance method self. It's just something that you say that it takes, because that way you can refer to the object you're working with when you actually write the method. It's something that you use when you're writing it, but not when you're calling it.
Yep. So yeah, we just defined this getPrice method or function. So any car will be able to call this function, and like you can get the price of any car object essentially. So we can demonstrate that here. Like if we create a new car object, so we can do car1 equals car. And this is how you call the constructor. Basically just do like the name of the class and then parentheses. And then within the parentheses, you put the things that you want to pass to the constructor. So here we need the color, year, make, and model. So red, 1, Camry,
Classic.
something like that, yeah. So yeah, you can get attributes of the car by doing like print car1 dot color, and this will give you the color. If you want to call a method within the class, you can do car1.getPrice. So basically what this is going to do is it's going to use this instance of a car object, so this specific red 2021 Toyota Camry, and it's going to call getPrice, and getPrice is going to, do all this logic based on like the year and the color, and come up with a price for this specific car. Yeah, so you can see here it's 29,000 because it's newer than 2018 and it's red. Oh, and then we're gonna set up another method here because we're about to talk about another concept called inheritance. So like, okay, we made another method here, and let's do $1.honk.
Hey, Bo.
So,
Yeah, so we have a question in the chat here asking about like what self means in this object as well.
So if you the answer, if you have any programming experience, or like if you're used to something in a different language, it's like the this keyword in Java. What it basically refers to is when you write a class, you are writing the generic code to manage any instance of the class that you make. So self is assuming that there will be a particular object of this class at some point that might have particular properties. This is like how we create a car that specifically has, a red color that was made in 2021, and it's a Toyota Camry. When you say, for instance, if you call getPrice on this, self is how it knows I am the car that has, that's a red 2021 Toyota Camry. It basically is just a programming construct that lets you grab particular properties about the instance that you are.
yeah.
So self lets you manage instances from the class itself.
Yeah, so on a very basic level, you can think of it as just like, this is how you tell Python, oh, I'm referring to like this specific like version of like specific object that like I want to change like, so like if I say like self.color, like I want to set like this specific object's color to red and not like, you know, like if I did like color here, maybe it would be like, you know, I'm trying to set like all cars color to red or something like that, but that's not what we want, right? We want to set like this specific object's properties to.
Maybe one thing I would say is like if we were, it would take a lot of time, but say if Bo and I made 10 different car variables here, the same code, just the car classes code is running for all 10 of those cars. So how it knows which car gets what is self points to the right car in every case. Like every time that the car method runs that code under the hood, it understands like, you know, this is me. And so self is basically telling the class which instance of the class it is.
Yeah, I think that's a great explanation. Okay, so now we're going to talk about inheritance, which is another huge concept within object-oriented programming. So basically, make another class here called truck, and how we tell Python that it inherits car is by putting car in the parentheses here. So essentially what this means on a conceptual level is that truck will inherit all of the properties in car. So you can think of it
for all intents and purposes is a car. It's made out of steel. It's constructed the same way. Like the you know, the init method is the same. When I say it's constructed the same, and you can call things like get price or honk on it without issue.
Yeah, exactly. So you can think of it like in real life, right? It's like the whole like a rectangle square thing. Like a rectangle is a square, but a square is not. Wait, a square is a rectangle, but a rectangle is not necessarily a square. But yeah, it's like that kind of relationship, right? So, you know, a truck is a car, but like you don't know if a car is necessarily a truck. So like, yeah, we can basically say that like Python already knows that truck has everything that a car has. So like
it saves you from having to reinvent the wheel. If you like the init method from car and you don't want to, and you don't need more functionality than what is in car, you don't have to rewrite any of that code.
Exactly. So like right now, truck has everything within car, but like obviously, if a truck was just like exactly the same as a car, then there wouldn't really be any point of creating a truck class, right? So we want to like maybe introduce some new functionality. So we can actually make a new constructor here. And this is gonna override the constructor that we have from a car. So like we can do like a truck still has all of these properties. But maybe like, you know, a truck also has the ability to like tow stuff, right? So we can make a new property called towing capacity. And here, there's like a kind of cool trick. Basically, we can call super, which I guess is another like pretty deep object-oriented principle. But essentially, super just means that we're referring back to the car class instead of the truck class.
And
so,
what it lets you do is access, if you can access the superclasses constructor, you don't have to redo any of that work when you're overriding this method, because each class only has one init method. So if you want to do all of the stuff that car does and some more stuff, you should call super's init method before you do any of your extra stuff. It's basically just a way of like saving or letting you carry over as much of the functionality as you want, which makes sense because, you know, a truck is a car. So you should be able to initialize all the stuff that you do for a car if you want. And then you're still at liberty to add some extra stuff.
Yep. So all this is doing is calling the init method we already made in car right there. And passing all of the relevant stuff. And then, of course, we have our new property, so we need to set that. Self.towing capacity. So I guess as a demonstration, like we can also create a new thing here. So this honk method is going to override the honk method we already made in car. So basically, if we have a car and we call honk, it's going to call this honk method. But if we have specifically a truck and we call honk, then it's going to call this honk method.
Which is totally just a toy example, but I just wanted to throw in like, an instance of what polymorphism is, which is just like you can have children that inherit from a class and they can still change things about the base functionality by overriding those methods.
Yeah, so you can see here now we're creating a truck and we're using the truck constructor. So we're passing all the things from car plus the towing capacity. And then you can see here, like we have access to everything that, you think we would have access to. So like you can do the towing capacity. You can also do things from the car class that we inherited. So you can do like truck1 dot price, and this should work perfectly fine. Yep. Oh. And you can see now, like if we call truck1's honk method, because it knows that it's a truck, it's gonna call this one. Yep. All right. Anyone have any questions about object-oriented programming in Python?
We just take questions for a few minutes. I'm thinking we had a small data science demo, but maybe we should just link it. I don't know if we can meaningfully break down pandas and NumPy and stuff like that in just 10 minutes.
Yeah, unfortunately, we probably won't have time to talk about NumPy and pandas and stuff, but I linked a cool demo exercise, just working with some basic data science stuff in Python. If you guys want to check it out, it's pretty cool example because you get to work with data from Chipotle and like work with the orders and stuff. And like if you ever use Python for data science, which is becoming like, super popular these days, like Python's definitely the #1 language for working with data science and machine learning and so on. You might end up like working with this kind of stuff. So it's just something kind of cool to check out if you guys have time.
Yeah, especially if you might, be working on a project that's sort of data wrangling related. That's a good spot to start. Any questions about object-oriented stuff? I know it's pretty it's pretty confusing on the first pass. Oh, I guess I'll go ahead and echo what's in chat too. Remember to sign in if you were here at this this workshop. Secret word is in chat. Are we good to wrap up? Do we have any questions?
Yeah, I think you can wrap up now.
All right.
Live stream if you need to.
Well, thank y'all for showing up to the workshop. We hope it was helpful. If you have any other questions, I'm sure you can find somebody on the Discord who is willing to help you out. There are lots of like Python resources. You can specifically send me a message if you have anything particular that you're interested in learning in Python.
Yeah, same goes for me. If you guys have any specific questions you think of, you can reach out to me on Discord anytime. And I put the link in the Zoom chat for the notebook. If you guys want to reference back to it or download it and check it out or anything like that. So yeah. Thanks, guys.
Shout out to Bo for being the one to screen share and actually write the code. Did the heavy lifting.
No. It was equal contribution for sure. Thank you,
Nate,
Nate.
you got carried.
I definitely did. All right. I think I'm due for a nap. Woke up at 10 and that was far too early.
Same. I think I should get some food. I have the Firebase workshop, right? Too.
Yeah.
Almost forgot about that one.
Yep. In an hour.